Okay, the problem states calculate the pH of a 0.036 molar nitrous acid solution. So in the problem they already give you the formula here, and based off of the question 2, you're dealing with nitrous acid, which is a weak acid, meaning that it won't fully dissociate within the solution. And that's also why we have the double arrow here, to state that there is some sort of equilibrium going on in this reaction. But we're also given the Ka, which is 4.5 times 10 to the negative 4, which we will be using later in this problem. So first, let's establish, or let's do an ice table. So you usually set up an ice table like this, and what you're going to be doing is writing your initial concentration. So this is initial, and this is going to be change, and this is going to be the value at equilibrium. So basically, from here, you just kind of put in the values where they're supposed to be. So it states here that we have 0.036 moles per liter of nitrous acid. So that value is your initial concentration of nitrous acid. So you can write it here. And they don't give you values for these two here, so you can assume their initial concentration is 0. Next you have the change. So basically, in this reaction, reactants are being reduced and products are being consumed. So to state that the reactants are being reduced, we'll put a minus X. And to state that the products are being consumed, we'll put a plus X. And then you simply combine the two rows to give you your equilibrium. So then you're left with this value. So now we're going to be writing your Ka expression, which is going to be, Ka is going to be equal to your products over your reactants. So it'll be the concentration, your hydrogen ions, and your NO2 minus, all over your reactants, of nitrous acid. So since we have the general formula, we can plug in our values that we have decided upon through our ice table. So our Ka will be equal to X times X all over 0.036 minus X. So again, if you can see where this comes from, the X's come from your product, and the 0.036 minus X comes from your reactant. Now, we know what Ka is as well, so we can plug that in. So I'm actually going to move my work over here. Sometimes, at least for me, I like to do things step by step. So I would suggest that for other people so that they don't get their work wrong. So I rewrote this problem here and put it over here just so I can add in my Ka value. As you can see, I just combined the x's to make the x squared is the exact same thing. And I took out the minus x here because technically people are much higher in knowledge than I am that know more about chemistry discovered that the minus x is so negligible in value that it doesn't even matter. So you can just take out that minus x and you're left with this. So basically it kind of just comes down to basic math. So how would you solve for x in this problem? So I would first multiply these two together, 4.5 times 10 to the negative 4 times 0.036, and you would get x squared equal to a very small number, Basically it's 0.000162 equals to x squared, and then how do you get just in 1x? You're going to get the square roots of both sides, and then x would be equal to still a very small number, which is going to be 0.00402. So now you have what x is. So technically what you've solved for here is what x is up here. You haven't solved for pH, you've just solved what x is. So pH is the concentration of hydrogen ions. So from the equation you can see here, you do have a concentration of H ions. And from here you can see that it only is x. So x is the concentration of H ions, which is essentially it's just the concentration of H plus ions. So you can take this value and plug it into your equation, which is to solve for pH, which is pH is equal to negative log of the concentration of H plus ions. So pH is going to be negative log of 0.00402. And again, we plugged in this here. That's the concentration of hydrogen ions. In the equation, you can put in your concentration of hydrogen ions in here to calculate for pH, and then you just plug that in. So by taking the negative log of this value, your pH comes out to 2.40, and that would be your answer.